Now, Hess law is important because, as I said before, direct determination of the enthalpy change of formations of carbon monoxide by experiments is impossible. Why? Because there are side reactions, there are side products. This is because carbon graphite reacts with oxygen to form both carbon monoxide and carbon dioxide. In other words, this is another example. Direct determination of the standard enthalpy change of formations of carbon monoxide is impossible. Let's write down its equation. Formation of carbon monoxide, that means carbon monoxide should be written on the product side. Carbon is one of the elements. O2 is another one. Bear in mind, keep this coefficient as 1, put half. Now imagine if you are doing direct determination, underline. Carbon reacts with oxygen to form a lot of products, such as carbon monoxide, carbon dioxide. Understand? Then it is impossible to determine this enthalpy change directly. We can determine the enthalpy change of formations of carbon monoxide indirectly by using Hess law. Now, please turn to page 7. Let's look at example 35.1. Determining standard enthalpy change of formations of carbon monoxide by applying Hess law. Now, bear in mind, every time while you are reading the question, you need to change into equation. Now, the question asks us to determine the standard enthalpy change of formations of carbon monoxide. Highlight it in green first. Change to equation. Formation of carbon dioxide. That means carbon monoxide, okay? Carbon monoxide is written as the product from its element. Its elements are graphite and half oxygen. This is our target. It was found from experiment that, now these are the experiments. Carbon graphite reacts with oxygen to form carbon dioxide with enthalpy change equal to negative 393.5 kJ per mole. And then another step. Carbon monoxide reacts with half O2 to form carbon dioxide with delta H2 equal to negative 283.0 kJ per mole. Use the above data, calculate the enthalpy change of formations of carbon monoxide. Now, there are several ways to solve the problem. I would like to show you this method first. Energy change cycle, because it is very common. Energy change cycle. Bear in mind, you must start your cycle by using your target reaction. Write down your target reaction horizontally. This is the first step. Next, look at the data given. This is the first data given. Carbon graphite reacts with oxygen to form carbon dioxide. Compare with your cycle. Here we have carbon graphite, okay? React with O2 to form carbon dioxide. So, pointing downwards, we have carbon dioxide. Carbon dioxide. However, you need to balance the equation. In this reaction, we need 1 O2. However, in this reaction, we have only half O2. So you need to add half more. Do you understand? Label it as delta H1. This is delta H1. And then delta H2, look at delta H2. We have carbon monoxide react with half O2 to form carbon dioxide. Look at your cycle. Here we have carbon monoxide, which is the reactant. And then here is the product. So we lay these two together by drawing an arrow. Bear in mind, you need to add half O2. Okay? So that everything's balanced in the cycle. This reaction have delta H2. Delta H2. And then in this example, we need to work out this delta HF. Now, first of all, I use two color pen to color two reactions, okay? This is the first. This is the root A. This is root A. And then these two are root. No, I'm wrong. Okay. Now, this is root A. And then this is also root A. This is also root A. Now, how to identify which two belongs to the same root? You may use the arrow. Now, this arrow pointing, you may consider clockwise. And then this arrow is also pointing clockwise. However, this arrow is pointing anti-clockwise. Then, for those are pointing in the same direction, that means these two belongs to the same root. However, this belongs to another root. Do you understand? After that, use Hess law. Because these two belongs to the same root, therefore delta HF plus delta H2 is equal to delta H1. Rearrange the equation because now we want to work out delta HF, which is equal to delta H1 minus delta H2. Lastly, substitute the data. Delta H1 negative 393.5 minus delta H2 283. Be careful about the sign, okay? So I need to draw a black cat. That means plus, finally negative 110. Negative 110.5 kilojoule per mole. That's the answer. Now let's discuss the second method by doing summation. But bear in mind our target. This is our target. Carbon graphite and half O2 on the reactant side. Carbon monoxide, 1 carbon monoxide on the product side. So let's use the data given. Here we have 1 graphite. So obviously, graphite, copy down this equation, plus O2, carbon dioxide, with delta H1 equal to negative 393.5 kilojoule per mole. And then next, now bear in mind this is our target. We want carbon monoxide. Can you see that the second equation, we have carbon monoxide, but on the reactant side. So please change the second equation, reverse the second equation. In reversing the equation, what do you need to do is to reverse the sign from negative to positive. Do you understand? Now, sum them up. You have CO2, one CO2 on the product side, one CO2 on the reactant side. So you can cancel them out. You have one O2, you have half O2. So you have half O2 on the reactant side. That is our target reaction. Lastly, what do you need to do is to do summation on these two terms. That means plus, which is also equal to negative 110.5 kilojoule per mole. This is another way to solve the problem.